Thank you for being here at 8. I first want to go and have a look at your results. Now I'm going to look at the full grade centers, so I'm not going to look at your individual classes. And just get this right. Okay, this is going to be like a quick one. You remember that to get a pass is 22.5, to get a 80 is 36. This is now the average of all your tests. Okay, so if I go down here slowly, see if you can pick up your name. That guy is on a 50, so there's somebody who's not on, who hasn't passed. I'm not sure which one you have not passed. Don't know if it will allow me to go to the, this one doesn't allow me to go to the right. Okay, so it looks to me like on the whole, there's one person here that has not done very well, and it seems to me that that person probably didn't write all their tests. If we go up here, they're like, am I in the right class? Yeah. So this person and this person need to speak to us. If you want to cancel, you must please cancel. Okay. Can I have some feedback? How's the tests going? Please speak to me. Do you want to say something? Is it okay? Are you managing? Okay, what about you, lady? How's it going with the tests? Is it okay? What about you, sir? Is it? Okay. How long do you take on average to prepare? 2 hours. Okay, anybody different or more or less the same? Okay, we need a bit of discussion. So if you don't discuss with me, I decide everything is okay. What do you say, sir? Right at the back left there. On your, yes, you. Not good, not bad. What is your marks? You don't know? Okay. Afterwards, come and check with Lunga what your marks are, okay? Right, let's go to where we are now. Lunga, can you just take them through this coming week, please? Are there any questions about the past week? Things you don't understand, things that are not, you're not happy with or whatever. Okay, let's go into here. This is for this week. Okay. Text. Are they there already? Okay. Okay. Good. If you look here, this is the module that we're going to be doing, 1.4, numbers and their operators. There already are 2 quizzes that you can use, and Lunga will just take you through the material that's up for this week.
Good morning, guys. This week we'll be learning on number systems and operators and constants. This is module 1.4. We already have the quizzes, open book quizzes, that was uploaded since last week. If you noticed, there's 2 of them for 1.4.1 and 1.4.2. If you go to 1.4.1, from 1.3, you learned about integers. Is that right? What's the difference between an integer and a float, and a floating point number? Sorry? You were saying something. Integers deals with whole numbers. And what about floating point numbers? They contain the fraction part. So if you can give an example of an integer, that would be just like 10. That's an integer. But if you say a float, that would be like 10.1, 10.2, because we have that fractional part after a comma. So how do we write floating point numbers in C++? Let's say we want to declare a variable that is a float, like temperature, 25.7 degrees. So in C++, if you want to declare a floating point number, you don't write it in words, like 25, 25 degrees or 7. You have to write the number in numbers, like this one. If you like some of us, when we write like fractional numbers, some of us use a comma to separate the number and the fractional part. But in programming like C++, that will result in errors, because The compiler will not recognize that number as a floating point number until you use a dot. Like you separate the number in the fractional part using a dot, like a full stop, 25.7. So if you use anything else other than that, then that will result in errors. So we've seen here the difference between an integer that is just 4, but now that once you have a dot 4.0, now that becomes a float. There they say 4 is an integer, 4.0 is a float. You can also see here from here that it's not a comma, it's a dot. Okay, we can also use floating point numbers. Like, can you read this number? That's like 300 million something, is it? But if you want to write a program very fast, do you really want to write this whole number, like 300, the 3 with the 9 other following zeros? So they say to avoid writing long numbers like this, you can actually write this number in scientific notations. I know you've used this maybe in physics. We use this mostly in physics. That is 3,10 to the exponent 8. That's 3 times 10 to the exponent 8, which will give you that 300 million. So when we declare floating point numbers, if you want to, from the previous work, when they say we declare an integer, we have int, which identifies the type. Int is the type of the variable that you want to declare, and then we have the name of the variable. That is what we call an identifier. For example, let me say you want to declare your age. Some of you may say, I'm 2.5 years old or 17.5 years old. But if you are filling a form and they ask you for your age, do you really write 17.5 or 18.5? You just write the whole number. So we can say that age is an integer. So if you want to declare age, you declare the type, which is an integer, and the identifier, that's the name of the variable, which is age. And then your variable, which is some of you are 18 years old, some of you are 20 years old. So if you want to capture, if I want to write a program that will capture the number, your ages in this class, like I say, some of you are 17, some of you are 18, then you'll understand that now age is a variable because it varies between you guys. Do you understand that? And if you want to declare floating point numbers, now we're not going to use int because now this is a different type. Like temperature, we say 25.5 25.5, let me not use comma, 25.5 degrees. So we will, when we declare it, we say the type, now it's a float. Then the identifier, which is temperature, and then our variable, 25.5 degrees Celsius or 30 degrees Celsius. So more differences on integers and float. What do you think the answer would be here? 10 divided by 4. If you see here, I is an integer, x is a float. 10 divided by 4. What is, in this case, I is an integer. Keep that in mind. So 10 divided by 4, what would be our answer there? Our answer would be an integer, right? Which is 2. But then now we have x, which is a float. And we still have 10 divided by 4. What's our answer there? 2.5. Because now we're dealing with floats, which means our answer should also contain the fractional part. So now you can see you can see from this example that floating point numbers are actually more accurate. If you write a test and they ask you what's the answer for 10 divided by 4 in a maths class, then you give them 2, are you going to get a mark? No. But if you write 2.5, you get an answer for that, which indicates to you that floating point numbers are more accurate than integers. So, let's see what's this. Let's go to operators. Operators are basically what we use for our mathematical calculations in programming. You know what that sign is? That's a plus sign. When do we use a plus sign? To add two numbers. A minus sign to subtract. That is a division. We use this forward slash because we don't have that normal where you have a dot and a line in between. We don't have that in the keyboard, so we use that forward slash. And for multiplication, we use an asterisk. What do you think that is for? That percentage sign. It's called modulo in programming. What do you think that is for? Sure. It gives the fractional part if you divide two numbers. What does anyone else say? Yes, sir. The remaining part, which is the remainder. What does anyone else say? The percentage. If you say 8 divided by 4, it gives you the 4 divided by 8 gives you the percentage, which is 50%. What does anyone LC. No one. What about the ladies? Yes, you. What do you say? Yes. You don't know. So the modulo, like our guy said at the back there, it gives us the remainder of two numbers. If we divide 5/3, it gives us the remainder of that. What's the remainder if you divide 5 by 3? That is 2, right? Yeah. So now here they explain what each operator does. These ones we've seen from here. Division, you use the /. Dividing by 0. What happens when you divide by 0? When you're programming, is it possible to divide by 0? It says dividing by 0 is strictly forbidden, which means by any case, if you're writing a program, do not divide by 0. That will result in errors. Addition, like we said, we use the normal plus sign. Subtraction, we use the normal minus sign. So we have a new term here that says unary minus. What do they mean by unary? Unary. What do they mean by unary? Okay. If you read there, it says we use the minus operator as the unary operator, as it expects only one argument. They should have. If you look at here, I is equals to minus 100 and j is equals to minus I. This is something that is possible in programming. If you're writing a mathematical test and they ask you, what is minus I? We have positive numbers and negative numbers. Then they specify that j is minus I. What is I in this case? It's still minus 100. So what would be I? It would be 100. So unary operators, we specify that our number is positive or negative. But if it's positive, you don't really need to put the plus sign to indicate that our number is positive, because the compiler already knows that if you don't have a sign before that number, then that means it's positive. But if you want to make it a negative number, you must specify using the minus sign. Unary plus, that means our number is positive. Like I said, you don't have to specify that it's positive by putting the plus sign. If you just write it like it's 100, then that's a positive number. Remainder, we get the remainder using the modulo, which is the percentage, that percentage sign. And priorities, you know, when you're doing math and there's multiple operators in there, there's 1 plus 2 times 100 divided by 3, then maybe again minus 0. You don't just go from left to right and just start with whatever you know. Maybe it's 1 plus 3, but then you have a times. You know that in maths there's a rule that they say is it a BOSMAN's rule, which brackets off first. That is the priority that they talk about also in programming. There's calculations that you must do first before you can do other operations. So these are the list of priorities. This is a table that shows which operators have the highest priorities in programming. So the highest priority first is that unary operators, positive and minus. Then you have your multiplication, division, and modulo. Then you have your binary operators, plus and minus, that is a plus b or a minus b. This one, unary, it means where you specify this number is a positive number or a negative number. But now that if it says it's binary, there's two, you are dealing with two variables. Binary means two. So it's either you are adding two variables or you are subtracting or you're finding the difference between those two. This is the list of priorities. This is a short quiz. What would be the answer here? 2 times 3 modulo 5. This is our list of priorities. This is what we are given. What would be the answer here? 1. Do we all agree?
person who said 1, tell us how you worked it out.
According to the priority, we first multiply 2 by 3. That's give us 6. And 6 move below 5. Let us find the remaining of the
Says the result is 1. Can you all see how we got to 1? It's clear. Okay. Parentheses, these are parentheses are these brackets in that we also use in maths. Like I told you, the rule that we have in maths, BOSMAN. So, like when you're doing a math equation calculation, and you have brackets in there. So the first thing you do is remove brackets first, which simply means that parentheses also in programming have that priority, the highest priority, which means you deal with the brackets first before you can do the next calculation. So we talked about declaring variables. We specify the type, and this is our identifier. And this is our variable. I think this is something that has to count the number of sheep. The number is an integer. Our variable is the sheep counter. Our identifier, at the moment, it's 0. Since it's a variable, that means it can change anytime. So, how do we count this number of sheep? If you want to count the number of sheep that are going into a what do they call it?
Crawl.
In a crawl. If one sheep crosses into the gate, that means you add 1 sheep. If another crosses in, that you add another sheep. So in here, they have a nice equation. Sheep counter equals to sheep counter plus 1, which means every time a sheep enters the crawl, we add 1. But we can simplify this with this expression here. Sheep counter equals to plus plus. Sheep counter plus plus. Sorry. It does the same effect as that, just that now it's shorter.
Okay, class, thanks, Lumga. Now, can I just say to you, we don't need to go through this step by step with you, but you now need to go, you see here, you can do the same with subtraction. Now, if you work your way through this, please pay attention to everything that is said here, okay? Uh, if we ask you what is an increment operator, what is a decrement operator, you need to know. Okay. You note here you can do it in front, you can do it in the rear. Okay. Now, go and look at the differences of this, and then come through right to the end here. And really, if you learn this, and you learn the order in which things are done, that will help you a lot, because a lot of errors in your program will come from this, using this wrongly. Okay. I just want to move in the last few minutes onto something else, which has to do with organization of the summative tests. I'm going to repeat it here, it's recorded, and we will also, when you write a summative test, we will give you a sheet that you have to sign off with all the rules of the summative tests. We had in another class last week, somebody sat there with a phone that was on, it was handed from one student to the other. Now, I want to make it clear to you, you're not allowed to have an electronic device on you in the lab when you're doing an assessment. Especially, it must not be on. Okay. Now, we would prefer that device to be in your bag. Okay. Let me just tell you what we have found before. We actually found people who were sitting in the lab and they WhatsApped the password to somebody sitting in the library who was doing an open book test on the assessment. Now, we will catch you out, okay? And I'm not a policeman, so if we catch you with, I don't even want to use the word catch you, because I don't want to catch you. So what I'm saying to you now, if you are found to have an electronic device that is on your person, that test, you will immediately lose that test. Is that clear? There's so many ways that people can cheat. But I don't want to say to you, you cheated, because sometimes you may just have forgotten that you have the device. So when you come and write an assessment, bring some kind of bag with you, backpack or something, put your devices in there. Don't even have them on you. It's not worth it. It's better to fail the test than to be caught out. And I will take this up with the registrar, but if we found you more than once, I don't know how many times, but if we find you doing this a number of times, we will actually ask that you be taken off the course. Okay? So please, do yourself a favor. Rather fail. Okay? Come to Lunga or me afterwards and say to me, I didn't do well. Rather get some clemency somewhere than try and beat the system. Okay? I think that's it. You also have to look at the other document, which will be a repeat. It's over here. It comes out of the other two documents. It comes from the C++ website. This stuff is fundamental. It's not theory. It's how you work something out. Any questions? Any comments? Anything from you, Lunga, that you want to say to them? You're okay. If you find that you don't get a result that is correct from your program, you've made a mistake with somewhere along here. So you really need to know this. Okay? Thanks a lot.